Foundations of Math 2, Unit 4, Solving Quadratics by Factoring. So the steps for this are written here. The zero product property tells you that if the product of two numbers is 0, then one of them must be 0. I'm sorry, that's bothering me. That is a crazy typo. If A times B is 0, then either A equals 0 or B equals 0, or both of them are 0. So if we factor a quadratic and get x plus 3 and x minus 5 equals 0, then the solutions are, you're going to set x plus 3 equal to 0 and x minus 5 equal to 0 and solve each of those individually, because when we multiply two things together and get 0, at least one of them is 0. So subtract 3 from both sides and you get x equals negative 3. Add 5 to both sides, you get x equals 5. Both cause the function to equal 0. So the steps are to set the quadratic equation in standard form. Standard form is ax squared plus bx plus c and equal to 0. So that's what it needs to look like. Factor it like we've been doing, and then use the zero product property to solve each factor. So the first one, with my GCF, I'm going to pull out my GCF here. 15 and 25 have a GCF of 5. X and x squared have an x. Dividing each of those, you get 3 plus 5x. Now this is factored and it equals 0, so I'm going to use the zero product property and set each piece equal to 0 and solve. Divide both sides by 5, you get x equals 0. Subtract 3, 5x equals negative 3. Divide both sides by 5, x equals negative 3/5. The next one, I can pull out an x squared, and I'm left with x squared minus 7 equals 0. So now I'm going to set each piece equal to 0. Take the square root of both sides, you get x equals 0 here. This one you got to add 7. X squared equals 7. Take the square root. Anytime you're solving an equation and you take the square root, you have to take the positive and negative square root. So we're going to say positive and negative square root of 7. You would simplify that radical if it was not already in simplest form. And if it asks you to round, then you'll type it in your calculator and round to whatever it asks you to round to. The next one, pulling out a 9x squared, and I'm left with x plus 2. And I divide each of those by 9x squared. So I have 9x squared equals 0 and x plus 2 equals 0. Divide both sides by 9 here. Take the square root. You get x equals 0. Subtract 2 from both sides. X equals negative 2. Difference of squares. This applies to quadratics that contain perfect square terms. They follow a factorable pattern of a plus b and a minus b. This is when you have a squared minus b squared, so you subtract them. So here, to factor this one, I take the square root of both. So I have x and 8. And in my trinomial, or in my binomials, I'll have x plus 8 in one and x minus 8 in the other. Set each piece equal to 0 using the zero product property. Subtract 8 from both sides, x equals negative 8. Add 8 to both sides, x equals positive 8. Or, when you have this one, you can solve this one using the equation because it doesn't have that middle term. So I'm going to add 64 to both sides. X squared equals 64. Take the square root of both sides. Remember, when you take the square root, you have to take the positive and negative square root. And so you have x equals plus and minus 8. So you can do either one. You can factor it or you can solve it. So number 3, I'm going to factor. So my quadratics here, my square roots, are 4x plus 9 and 4x minus 9. Take the square root of each piece. So that equals 0. I have 4x plus 9 equals 0. and 4x minus 9 equals 0. Solve both of those, subtract 9 from both sides. 4x equals negative 9. Divide both sides by 4. X equals negative 9/4. The next one, add 9 to both sides. 4x equals 9. Divide both sides by 4. X equals positive 9/4. The next one, this one's already set up to solve it by taking the square root. So I'm just going to take the square root of both sides, and I have x equals plus and minus 12, because 12 times 12 is 144. And here I'm going to do the same thing. I'm going to divide both sides by 100. And I have x squared equals 9 over 100. Take the square root of both sides. You have x equals plus and minus. When you're taking the square root of a fraction, you can take the square root of each piece. And you get 3 over 10. On back, using the box method. The box method is a method to use for trinomials where a is greater than 1. Okay, a is greater than 1. So I'm going to use my box method to factor. So I have 6x squared and 4, because there's no GCF here. 6 times 4 is 24. My factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. To get 11, I need to use 3 and 8. Positive 11 will be positive 3x and positive 8x. Pulling out my GCF, I have 2x here and 1 there. This way, I have 3x and 4. So I have 3x plus 4 and 2x plus 1. Now I'm going to set each of those equal to 0 separately and solve. Subtract 4. Divide both sides by 3. X equals negative 4/3. Subtract 1. Divide both sides by 2. X equals negative 1/2. The next one is not set equal to 0, so I need to add that 12 to both sides to set it equal to 0. And then I'm going to use the box method like I just did. 5x squared and 12. 5 times 12 is 60. List my factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9, I don't think go in. So I need it to equal negative 17. To get negative 17, I'm going to use 3 and 20. And 20 will be negative. 3 minus 20 is 17, negative 17. So I have 3x in one and negative 20x in the other. Pull out my GCF. I have 5x here and 3 here. This way, they only have an x in common. And this way, we have a negative 4 in common. We want the greatest common factor. So I have 5x plus 3 and x minus 4 equals 0. Set each piece equal to 0 separately. Subtract 3 from both sides. 5x equals negative 3. Divide both sides by 5. X equals negative 3/5. Add 4 to both sides. X equals positive 4. And the last one, again, not set equal to 0, so I'm going to move my x over and my 1. So I have 2x squared minus x minus 1 equals 0. Use my box method. 2x squared and negative 1. 2 times negative 1 is negative 2. My factors of 2 are just 1 and 2. To get negative 1x, I need to have positive 1 and negative 2. So I have 1x in one and negative 2x in the other. Pull out your GCF. I have 2x here, 1 there, x here, and negative 1 there because of this negative. So I have 2x plus 1 times x minus 1 equals 0. Set each piece equal to 0 separately using the zero product property. Subtract 1 from both sides. Divide both sides by 2. X equals -1/2. Add 1 to both sides. X equals 1. And then mixed examples. This one, I am going to solve it just adding my 25 to both sides. You could also use difference of squares, and it would be factored x plus 5, x minus 5 equals 0. And do it that way. So I have x squared equals 25. Take the square root of both sides. X equals plus and minus 5. Sorry, my formatting, my column didn't put it there for some reason. The next one, I'm going to factor using the box method. 3x squared and -21. 3 times -21 is -63. Factors of 63, 1 and 63. 2 doesn't go in. 3 and 21. 4, 5, 6, nope, 7 and 9. To get 2, I'm going to use 7 and 9. I'm going to use positive 9 and -7. So I have -7x in one and 9x in the other. Pulling out my GCF, I have 3x and -7. Here I have just x and 3. So I have 3x minus 7 times x plus 3. Use the zero product property to set each one equal to 0 and solve. And the last one, x squared minus x equals 12. I'm going to set it equal to 0. Subtract 12 from both sides. So I have x squared minus x minus 12 equals 0. This one I'm going to factor. We have a equals 1, so I can just list my factors of c. 1 and 12, 2 and 6, 3 and 4. To get -1, I'm going to use 3 and 4, -4. So I have x plus 3 and x minus 4. Set each piece equal to 0 using the zero product property to solve. Subtract 3 from both sides here, x equals -3. Add 4 to both sides here, x equals 4. You can graph these in your calculator, and we will talk about that.